Welcome to qnawire.
Okay, this is problem 2874, and we have two long straight conductors with a square cross-section, and they're each carrying a current I. This top conductor is carrying a current I, and the current is pointing out of the page, so towards us. And then the bottom conductor is carrying a current into the page, so away from us. And we want to determine the net magnetic field at these 3 points, point P, R, and S. And this question gives us a hint and says, refer to problem 2873. So the key thing that we need to remember from that other problem is that the magnetic field due to an infinite sheet of current is going to be B equals mu naught times I times N divided by 2. So this is the key thing that we need to know. So let's consider point P up here. We know that we have two sheets of current, so we're just going to want to add them up. So we'll have like B total is going to be B1 plus B2. And both of these are infinite sheets of current, so we can just plug this right in. And the bottom sheet has current I. The top sheet also has current I. But remember that the currents here are in opposite directions. So this top current, we can actually find the direction of the magnetic field by using the right-hand rule. So if we point our thumb out from the page, our fingers are going to curl to the left up here. So this bottom current has a magnetic field going to the left at point P. And similarly, the magnetic field from this bottom sheet is going to be going to the right. So notice that the magnitudes of these two magnetic fields are the same, but they're going to result in magnetic fields going in the opposite direction. So when we add these together, they're just going to cancel out and be equal to 0. So this is what we're going to get at point P. Now let's take a look at point R. So at point R, again, basically we're just going to add up the sum of the contribution from the top wire here. And again, using the right-hand rule, we know that the top conductor, sorry, not the top wire, the top conductor is going to give a magnetic field pointing to the right at point R. And when we use the right-hand rule, again, for the bottom conductor, we'll see that that will also create a net magnetic field pointing to the right. So when we add these together, they again have the same magnitude. We're adding the same two terms, but they're going to actually add up. They're not going to cancel out because they're resulting, they both are magnetic fields pointing in the same direction. So when we add these up, this is essentially just 1/2 of this quantity plus 1/2 of this quantity. So when we add it up, we're just going to get that the total B is equal to mu naught times I times N. And again, this is going to be pointing to the right. So I'll just specify that here. So that's at point R. Now we want to look at point S down here. Now again, you can kind of just look at the symmetry of the problem here and notice that point S is going to be the same situation as point P. So we're going to have, again, in this case, one of these magnetic fields is going to be pointing to the left, the other is going to be pointing to the right, but their magnitudes are the same. So these are just going to cancel out and again, just result in a net magnetic field equal to 0.